Thanks for joining us for this Vulcan webinar. Today, Maptek Technical Sales Manager, Mine Planning Solutions, Steve Sullivan, will outline why Vulcan is the preferred choice for resource geologists. You will learn how the upcoming version of Vulcan can be used for all your resource geology needs, offering enhanced variography, streamlined workflows, and faster performance. My name is Susanna Mackay and I'm a Technical Services Geologist for Maptek based in Newcastle. Over the last few years, we've seen a clear shift here at coal mines on the East Coast, and our customers' resource modelling needs are constantly evolving. Steve, you travel around Australia and Asia in your role. What is the current state of resource modelling and what is impacting that?
Hi Susanna, a few observations. The coal industry turned upwards nearly 2 years ago, with the metals markets joining in over the last 12 months. It generally takes about a year before these markets accept the change in prices have taken a new direction. And with that upward kick, we've experienced the change from a staunch cost-cutting mentality to one of cautious expansion, creating a demand in the requirement for both our services and software.
So what challenges do you see customers facing with the new market conditions?
Firstly, there's not enough people to do the jobs required, leading to a reliance on technology. Unfortunately, a lot of this technology is fragmented with lots of different interfaces and ways of operation. There's a need for rationalisation and consolidation to fully integrate these systems, covering a full range of technical applications. On a positive note, we're currently experiencing a return of many past customers, and of course we happily welcome them back to our user community.
And what are the future technology trends that clients ask you about?
There's a lot of noise around cloud enablement, Internet of Things, software as a service, predictive analytics and disruption, but there's also the need for functional, reliable and stable systems. Maptek has a pragmatic roadmap for our products based on customer interaction, balancing the latest in IT architecture and concepts with the delivery of new integrated functionality.
So when you're speaking to clients about why they have chosen Vulcan for their resource geology modelling, what are the common factors?
I'll pick out 3 points for discussion today. The comprehensive suite of integrated tools, whereby our products will cover the range of exploration, database management, geophysics, stratigraphic modelling, metalliferous modelling, implicit modelling, explicit modelling, geostatistics, geotechnical evaluation, validation, reserves and reconciliation, all within a seamlessly integrated environment, which then connect with end users from the mine planning and survey from the technical services. So a complete suite that is seamlessly integrated. Secondly, every version of our software leverages from the expertise from our global customer base, whose ideas and solutions are embedded in every new release. This functionality is distributed to all customers who are under current software maintenance. So Maptek is offering a mentoring software capability. And thirdly, reducing the reliance on multiple software platforms gains you the ability of ease of learning for your staff, auditable in-house processes with a very consistent workflow. It removes the import-export processes when you have multiple vendors, simplifies your software administration, and importantly, it lowers the annual maintenance costs. So with these 3 principles in mind, let's move on to some of the features of the upcoming version of Vulcan 11, scheduled for release later on this year. So we'll pick 3 points here from the geology space that we're going to have a look at. These are all new functions that are going to be delivered in Vulcan 11. So we'll cut live now and have a look at the Vulcan Data Analyser, the new block variography and the data highlighting capabilities, the Kriging neighbourhood analysis under block grade estimation, and the Geological sculpting tool. So jumping first of all into our demonstration database here, we have a topography, we have some drill holes, we have a block model and some ore bodies on the screen there. It's one of our standard training data sets, and we'll use that to show some of the new capabilities. And for those that have used Vulcan 10, we have the Data Analyzer available under Analyze Data Analyzer. And I already have that loaded, so we'll have a look here. And previously, we could use and generate information from a database, a variogram from a database. So in this case here, I've got the copper from a database with a filter on it, and I'm looking at a variogram here in red showing the variability of copper with distance, and I'm showing a model of that has been made and saved in the Vulcan Data Analyser. So that's current functionality. The new functionality is now the ability to do that with block models. So I have here a block model which is derived from the same drill hole database that we saw on the screen. If I go to variography now, and you'll see that the variogram option is now active and live. So to use that function, I click on the variogram button. You'll notice a properties window over here to the right. I can input values of my search radius, different offsets in terms of the orientation, and when I'm happy with that, I can generate that variogram. Down here, you'll see a progress bar indicating that we're generating the chart. This is a block model with about 5 million blocks, so it's taking maybe 20-30 seconds to grab that information. Now you'll notice I've clicked on two variables here. I've got a copper that's been estimated with inverse distance and a copper which has been estimated with ordinary Kriging, and those two charts, those variograms, have appeared on the screen from the block model. As well as generating a variogram, Vulcan and the Data Analyser has also generated a range of different things simultaneously. Okay, so first of all, I'll just put on the number of pairs so you can see the number of pairs of points that have been found in each one. And we'll just cycle through looking at the covariance function, the parallelogram, general relative semi-variogram, the pairwise relative semi-variogram, the rhodogram, and then the matogram. So all of those are generated simultaneously and can be charted and plotted like other functions that we've had also in Vulcan Data Analyser. So moving on from the new block variography, the next one in the Data Analyser which is new is the data connectivity, whereby information on a chart can be then demonstrated in 3D into Vulcan on the 3D graphics. So we'll start here with our generating from our block model, and we can use the drill hole database, but I've got a block model open, so let's use that. Let's generate a histogram of those variables. We have both the copper inverse distance and the copper ordinary Kriging. There we have the chart there, and a second chart here. So in this instance, I've got copper with inverse distance. I've got a population out here in 5%, a bin of information there. If I now go to the connectivity tool here and hit our highlight, make sure highlight is active. If I click on that particular bin there, you'll see that it shades into a blue. And if I open up the Visage window and say remove our surfaces here so we can see, and zoom in, you'll see that there's a range of blocks there. And those blocks there, those are the centroid of the blocks that comply with what's on that chart. So if I just zoom out again and maybe go back to the analyzer and select the bigger selection, so we see all those three bins, and it will now update the 3D graphics showing you the distribution, the XYZ positions of information that sits there on the chart. So very powerful functionality and allowing you to look at the 2D statistics and look at how the spatial location of that data is. Okay, so that is with the histogram. That's similar functionality if we now go back to our stats and generate a cumulative frequency chart for both those. Again, that'll take a few seconds just to generate that chart from the block model. And these charts often look better with a logarithm. So you have a logarithm there. Now, again, if you wanted to say, let's select part of one of these, let's just have a look at where the data is, where that break in slope is. From the CDF, we can now have a look back into 3D, and it will show that information. So information that I selected on the graph is spatially located throughout that area there. And the final chart type here, because we've got two variables, we can do a scatter plot of those two variables. And again, this same capability of highlighting back into 3 dimensions is available. So I'll just put a trend line there linear fit, and we'll give it a different color. So we have here a chart showing the correlation between the two different variables. I can put the stats there, so there's a reasonable correlation between those over here. Now, if I wanted to see where an outlier, so I wanted to have a look at where that value is there. It's just a single point. It loads up that single point in space, and I can locate that data there. And just to confirm on the chart there, that information is fairly high grade, above 5-6% in the block model. We can go back to the 3D and have a look at the original assays in the drill hole, which is loaded on the screen there. And if I have a look at copper there, remember this is a block centroid, so there will be some averaging and smoothing, but there we are. We have a high grade area there with samples above 5% up to 10%. So each of those centroids of those blocks there are taking on a value that is between 5.5, is around 5.5 there. So that's where that. Now you could also take a larger slab of data. So I want to look at a different range, and you can go back and select different information. And Vulcan updates that in the 3D graphics. Just zoom out and you'll be able to find where those samples are. So that data highlighting is new and will be available in Vulcan 11. The second part of the demonstration here is to move to another new function, and that is the Kriging neighbourhood analysis, which can be found under the block grade estimation menu, Kriging neighbourhood analysis. Now, the idea behind this is to look at the parameters that you use as inputs to the Kriging process, and to understand and see the impact of changing each of the individual parameters, and see what the impact is on the Kriging estimate. So the idea is here we're looking to reduce or minimize the conditional bias, and so what we're using is a couple of parameters: the slope of regression and the Kriging efficiency, and we're trying to get them as close as possible as we can to 1. So let's open up this function. Like a lot of other Vulcan panels, you set up a specification file and you run that specification file. That means that you can go back and use that later with all the settings. So I've saved one here, and now there's two different types. You can do a local analysis and a global analysis. A local analysis is a single block, and you then look at all the parameters based on that single block. A global analysis allows you to look at a spatial region, so it might be part of a domain or a whole domain, and look at the parameters based on all of the blocks in that domain. So we'll start with simple. What it relies on as input is a variogram. So here we have a variogram that I've generated from the Vulcan Data Analyser. We have a samples database. In this case, it's a composite database. We have a search orientation. We have a single coordinate that we're using for the block centroid. Then we go through and use flagging within the database, a very standard Vulcan panel. So we select the field that we want to work with. We've got different filters for number of samples per drill hole, number of drill holes per estimate. We've used numeric tags and character tags, solid triangulations, and field restrictions. Once we've selected the data we want to use, we then select the blocks that we want to write to. And in this case, I'm constraining it to a specific triangulation region. Then we come to the analysis itself, and the Kriging neighbourhood analysis allows us to evaluate the block size, the number of samples, both the minimum and maximum, the search radius in each of the 3 orientations, and the discretization steps in 3 orientations. So we do those one at a time sequentially. So I'll start off with the block size. So I'm looking at a minimum block size of 5 up to 20 with a step of 5. So there'll be 4 different ones, and I'm doing that in those 3 orientations, and the Z I'm just leaving it at 5. Regular or non-regular blocks. So to do this, we just apply and run. It will take about 30 seconds to a minute to run using this block model with about 5 million blocks, and it will generate a chart that we can have a look at. From that chart, we'll be able to then select the values that we want to use. Now, this new function has been tested on numerous data sets and is available for beta testing, and will be, as I say, released later on this year. Okay, so we've generated our chart. Now what we have on the x-axis here is the block dimensions, and we have all the different permutations of block dimensions as per the settings in our panel. Then we have here on the left-hand side the Kriging efficiency in blue, and on the right-hand side we have the slope of regression in red. And you can see the different values based on for the different block sizes. So we're looking for values that are closest to 1. So really, ones up this end are showing you a better block size to use for your Kriging than the ones at this end. So in this case, I've chosen for argument's sake 5 by 5 by 5. I can then put that information in here, put my 5 by 5 in here. I can use that as a set. Then I can run the next set of parameters, look at the minimum and maximum number of samples. Now, as you saw, that took about a minute to run. So for this webinar, I'll just grab some that I did earlier. And when you have this little chart, you've got a save button here, and you just save that figure for your reporting purposes. So I'll just grab the couple of others to show you what we look at here. The minimum and maximum samples looks like this. Okay, so we start off with, I start off with 4 samples for the estimate, right up to 24. And again, you see we're improving our estimates the more samples we've got. So you can choose a maximum, and then you can pick off a minimum here at a level where you are happy with the assessment. The next one to look at is the search radius. So we're looking at the search radius. We have different sets again that we've set up, and again you can see the improvement towards this end of these sets of parameters here. So that's the third panel here, and the final panel is the discretization. So if I go back to my charting here, the discretization for the local one, and you can see here this one's almost an inverse relationship between slope of regression here and then the Kriging efficiency. But you'll notice that the numbers here, really there's not a lot of difference between any of these, because they're all they're only in the 3rd decimal place we're getting any variation. So saying at this particular deposit, there's not a lot of sensitivity in your discretization. So those are 4 different types of optimization that you can look at. And the beauty about this is after you've set up your optimization, you can then run the estimate using the optimal parameters into your block model. So this in effect is writing your block estimation file or BF file for you, and then letting that run. So it not only gives you the parameters to use, it enables you to use those parameters and improve your workflow and get everything working in a smooth fashion. Just the last one here will just show you the global analysis, and this is where you can look at a spatial region of multiple blocks. And going back to the pre-prepared ones, if I'm looking at my block size here now, what the chart looks a little bit different is the fact that we're looking at multiple blocks. So for each set of parameters on our block size, we now have a range from the minimum to the maximum. We have the median value and the average value, the mean value, and then we have the 50 percentile in here. So for each of these charts now, when we look at them, you'll get a range of different things to look at. So here's the minimum maximum samples. Then we have a look at our global search. So we get a range there. And finally, we have a look at our discretization. And very uniform, much like the local one, there's not a lot of variation in that. So that's the new Kriging neighborhood analysis, which is under the block grade estimation menu. Again, all this functionality that we're talking about is all integrated into the same interface. And the third function we want to look at in this session is the geological sculpting, which can be found under the geology menu. Now, the geological sculpting is an advanced tool for manipulating 2D surfaces and solids. Because as a geologist, we've got a lot of automated tools, implicit modeling, explicit modeling, and they can come up with some very complex shapes. But sometimes you need an extra tool just to get that shape right, just to match the model that's in your brain, in your head, with the one that you want to use in your resource modeling. So this geological sculpting tool allows you to do that advanced editing. And the way it works, I'm just choosing a topography here. We have a radius of influence, so I can choose 100 to show you how that works. I can select a point, so a point here, and that's giving me an influence of 100 meters, and I can just move that facets or series of facets to a new position. Now, if I don't like that position, I can undo that and go back to the previous state. So if I just change that now to 500, show you the influence of 500 for the same area, you'll see that now I'm bringing up a larger, or having more influence on that terrain with the 500 meter influence. And again, I right click, I can just undo that back to the previous state. Now if I go back to the 100 scenario and edit that up there, I'll grab another one like that. Now, for some reasons, you may want to get these things very close, and they may cross or they may go behind, but you don't really know. So we have now a tool, if I just undo that, a tool here which allows you to show where the active crossings are. So if I was to do that again, there, maybe zoom in a bit, we have a look, come up with another point. So these two are independent, but as soon as I go over here, you'll start to see that there's crossings there, and you can then reverse that back. And if I grab one again, while you're still doing it, you can see they're all crossing. You don't want crossing triangles because later on in the modelling process, in the block model, and also when you're doing reserving and passing data to engineers, etc., it will cause problems. So we don't want to do that. So that's an interactive tool which allows us to say, hey, look, that's happening. Let's prevent that from happening. So now there's another tool here available, and I'll just increase the influence there, increase the influence here, which allows us to use a reference line being a CAD object in Vulcan, so it's a line that you've digitized. I can go to my design database and select a layer of digitizing. I can extract that from the database and activate that, so you could have one or a series of those. And now when I run that, it moves all the data based on our influence here, these influence radiuses on that by that amount. So I'll just maybe just undo those ones, back there, go back to only 100 there, might be a bit more obvious, and let's just try running that. And so every point on this line, the data is now come to match that point using our radiuses and our influence distances. So you can see that there's 4 points, 5 or 6 points on that line, and they've now an option to save that. So I'll grab that line again just to show you. So you can use your design data to really control exactly where you want these surfaces to go. So here we are here, and if I just highlight the points on that object, the point display, so you can see there, wherever there was a point, that's where that influence has been on that surface. So that's geological sculpting, and it allows you to manipulate further and correct and get right your geological models, both 2D and 3D. So that brings us to the end of the demonstration for this session, Susanna, so it's back to you.
Thanks for such a detailed presentation on some of the new geostatistics and surface modelling functions. Steve, what Vulcan modules do users need to access these new tools when they come out?
For the first two functions I show, that's the Vulcan Data Analyser and the Kriging neighbourhood analysis. They'll be available on release of Vulcan 11 for those that have got to currently maintain a Geostat modeler license. The last one, the third one, the Geological Sculpting tool, is a module available for purchase separately, and customers can contact their local Maptek office for pricing.
Thanks again, Steve, for the showcase of Vulcan 11's new resource geology features. Customers with current software maintenance can download the latest version of Vulcan from users.maptek.com. As you can see, Vulcan 10.1.4 is available now. Of course, if you have any questions about Vulcan, please contact your local Maptek office for assistance. You can find all the relevant contact details on our website. If you'd like to view this webinar again or share this with your colleagues, it is available online at maptek.com. And while you're there, you can catch up on our other webinars covering a whole range of topics. Coming up in the Geology series, we will be covering stratigraphic enhancements, grade estimations and simulations, updates to implicit modelling, and Vulcan workflow and scripting functions. We'll be running additional webinars about Vulcan in the near future. Thanks again for watching.